In this lecture, we'll delve into the concept of partial objects and functions in Python, a topic that might initially seem abstract, but holds significant practical value in various programming scenarios. Partial functions, a concept borrowed from mathematics, allows us to fix a certain number of arguments of a function, creating a new version that requires fewer arguments. This is particularly useful in scenarios where we repeatedly apply a function with several common arguments. To illustrate the concept of partial functions in a different context, let's utilize Python's built-in filter function to demonstrate. The filter function is used to construct an iterator from elements of an iterable for which the function returns true. Suppose we frequently need to filter a list to include only the even numbers. The scenario is a prime example of a situation where a partial function can be useful. Normally, you would define a function that checks if a number is even, like lambda x colon x mod 2 double equals 0, and pass this as the first argument to filter. However, if you find yourself repeatedly applying this same lambda function in different filter calls, you are essentially creating a partial function of filter function iterable, where function is always lambda x x mod 2 double equals 0. Using the functools.partial method, therefore, you can create a new function that has lambda x colon x mod 2 double equals 0 pre-specified and only requires the iterable to be passed to it. This new function will then behave as a filter for even numbers version of the original filter function that you were using repetitively with the same arguments. Certain practical applications of partial functions include, for instance, in the realm of streaming log processing, you could imagine a scenario where we're processing streaming logs, and we consistently need to apply a function to these logs with some parameters that are fixed. Using partial functions can simplify our code in this case by reducing redundancy. In our genome pattern recognition example that we've been using in previous lectures and hands-ons, there could be certain calculations that might need to be repeatedly applied to genomic sequences with some fixed parameters. Here again, partial functions could be employed to streamline the analysis process. And finally, in stock price anomaly detection, or in financial analysis in general, detecting anomalies might require applying the same function with some standard thresholds or parameters. Partial functions can make these operations more efficient and readable by fixing arguments that need not be repeated in multiple calls. Some of the advantages of using partial functions include reducing code redundancy. It allows us to avoid repetitively writing the same arguments, making the code cleaner and more maintainable. And using partial functions also enhances the readability of our code. Code becomes more readable as the focus shifts to the varying arguments, which are often the critical part of the function's application. In summary, partial functions provide a way to freeze some portion of a function's arguments, leading to more concise and readable code. Let's now head over to the hands-on coding session to see partial functions in action. See you in a moment.